So we're going to continue our discussion of summations. And so I want to start by saying you might see a summation with an explicit formula. So let's look at some examples here of these. A summation from k equals 1 to infinity, k squared, or a summation from I equals 1 to 8 of negative 1 to the I over I plus 1. So there might be some kind of explicit formula here given for the summation. So let's look at some examples here. Let's say I want to compute the summation from k equals 1 to 5 of k squared. So remember, when you're writing out these summations, we're going to write it out in expanded form. You start with your lower bound there being 1. You plug that in for k, so you'd get 1 squared, and then 2 squared, 3 squared, 4 squared, and then you stop at your upper bound, so 5 squared. So here, if you add up all of these numbers, you would get 55. So all you're doing is substituting in for the k, all of the possible values, and then adding the numbers together. So let's look at another problem. Let's say I want to write a summation from I equals 0 to n, negative 1 to the I over I plus 1. I want to write this in expanded form. So you want to write it, you don't want to use summation notation now. So you're going to start out here, we're going to write our summation. You're going to, again, start with your lower bound or lower limit there. I is 0, so that's going to be your first value you plug in for I. Then your next value would be I equals 1. I would be 2. And then you keep going and you stop. In this case, I don't have a fixed number up here. I have n is my last one I plug in, so I plug in n in place of I. So if you simplify this, this would be 1 over 1 plus negative 1 over 2 plus 1 over 3 and if you want to, you could simplify that first one further. It's just 1 minus a half plus 1/3. The next term, it's going to be alternating, right? Flipping sign back and forth. So the next one would be minus 1/4 and so on until you end at negative 1 to the n over n plus 1. So that would be my summation written out in expanded form. So let's look at one more of these. So let's say express the following using summation notation. So 1 over n plus 2 over n plus 1 plus 3 over n plus 2, and it ends at n plus 1 over 2n. So if we're trying to write this in summation notation, we've got to notice patterns. So you've got a numerator and denominator. Let's start with the denominator. Do you see how a pattern with the denominator, it's n plus 1, n plus 2, so it keeps going up by 1 here. And 2n, you can think of that as really being like n plus n. That's the same thing as 2n. So the denominator has this pattern where it's always n plus a number. So I can write this as the summation. I'm going to use the variable I. So it's going to be, before I write that, we're going to write the denominator, it's n plus I. And what's my first denominator? It's n, so I is 0. And my last denominator, I would have to be n in order for me to get to 2n. And now let's look at the numerator. The numerator, do we have a pattern for the numerator? It starts off with 1, 2, 3. It's going up by 1. So it's not going to be I, because I starts off at 0. It'll be I plus 1. So if you plug in 0, you'll get 1. If you plug in 1, you'll get 2, and so forth. So this is my formula for summation notation. Okay. So again, make sure you notice, key thing here, when you're trying to write summation notation, you have to observe patterns in order to write a formula in general.